Now, the same way that we did a confidence interval for the population proportion, we can also do a confidence interval for the population mean. Okay? Now, some things are going to change on this. Change, yeah, I know how you guys are with change. It's not always a positive thing, but we'll try to make it as seamless as possible, okay? So we're going to start off with a point estimate. Same way we started off with p hat in the previous videos, we're going to start off with an x bar here. And remember, x bar is just going to be a point estimate for what my population mean is going to be. So I'm looking at getting my hands on the best estimate I can for the whole population. And so we're going to be using this study a lot. We've got an acupuncture study to determine how effective it is in relieving pain. And so we're going to measure the sensory rates of 15 subjects with the results given. Use the sample data to estimate the population mean rate. Okay? So my best estimation of the population right now is going to be whatever I find from this sample, my x bar. And so I typed in all this data into my L1 and then found my x bar to be 8.23. And that's what we'll be using. Okay? I could also just simply add up all 15 of these numbers and divide by 15. You would still get 8.23. And so, excuse me, that's my best guess for what is this, the sensory rate, how effective this acupuncture study is as far as the sensory rate goes. Now, since we're dealing with a population mean this time, I'm going to have to switch from using my Z table and use something called a T table, or a T distribution. So suppose that a simple random sample of size n is taken from the population, just like we did 15 acupuncture people on the last example. If the population of this sample follows a normal distribution, and I'm going to assume that it does, then I'm going to be able to find the t-score using this formula. Okay? And it follows with n minus 1 degrees of freedom. We'll talk about that here in a little bit. What I want you to see on this is that this isn't just real far off from what we had with our z-score. Remember, whenever we did the z-score, we took how tall Maria Sharapova was, x, subtracted off the mu, how tall the average height of a woman was, and divided it by the standard deviation. This time, I'm just putting in my mean right here, subtracting off what I should get for the mean, my population mean, which will hopefully be very close. And then dividing it by, well, this is just a standard deviation for the sample mean, s divided by square root of n. That's the same one we used in the last unit. So we're not real far off on using this z-table. And some books will actually just go ahead and teach this whole lesson using a z-table. I'm wanting to switch over to the t-table for what we're going to need, though. Now, it's a little bit different. Okay, let's talk about the differences and the similarities of this. Okay, so it is still going to be a normal shaped curve. Okay, but it's a little bit different. If I have a different degrees of freedom, it might come up a little faster and then come down. Okay, and we'll talk about that in just a little bit. But no matter which one it is, whether it's the red or the blue curve, my t distribution is going to be centered at 0. Just like my z distribution was. Okay? The total area underneath both of these curves is 1. And so that means I have 50% of my area to the left of this line, and I have 50% of my area to the right of this line. As t increases or decreases without bound, it never comes down all the way to 0. It's going to get really close to 0. It's going to approach 0, but it's never going to quite get there. It's going to look like it does, but it's never going to quite get there. Okay? All looking very familiar, I hope. This is very similar. Now, the area in the tails of a t distribution is going to be a little bit greater than the area in the tails of a z distribution. I'll show that on the next slide. Okay? But what I want you to know is because of the law of large numbers, the more people I can survey in my sample mean to estimate what my population mean is going to be, the closer I'm going to actually get to the z-table. I'll be able to show you that hopefully before the end of this video. But here's some examples of some t-distribution. Like I said, there's more than one. So we've been working with this blue line right here. Okay, that blue line is my standard normal curve. Now the orange line, let's go to this orange line right here. The orange line, look how much more area is down here in the tails below the orange line versus below the blue line. That's the main difference I want you to see with the t-distribution, is that it tends to have more area in the tails. That means it's going to be a little bit less up here. That's all right. But it just stretches the tails out a little bit. Now, if I was to up my sample size to 15, look how much closer this pink line. Is that pink? Yeah, I guess it's pink. Look how much closer this pink line is getting to this blue line. So eventually, as n grows and grows and grows and grows, this orange line is going to eventually become the pink line, and that pink line is going to eventually become the blue line if I can get n to be large. What's large? We will see on some examples. Another big difference I want you to know with my t-distribution is that whenever, again, we can do all this in the graphing calculator, but I'm looking at my 20 graphing calculators in the back of the book and know that many of you don't have one. So I'm going to be going back to old school and using a table on this. If you do have a graphing calculator, have it ready during the Q&A, and I'll be glad to show you the shortcuts. And so another big thing on this is that whenever we talk about our t-distribution and we look at our curve in the table we're going to be using, we're going to be using the area to the right of the curve. And I do believe that the t-table that I included in Google Classroom mentions this at the top. I'm not sure if it does or not. Well, we'll see in just a minute. So let's just practice that real quick. I want to find a t-value such that the area under the t-distribution to the right of the t-value is 0.2. Okay, let's draw that real quick. So I've got my normal distribution. I want this area over here to be 0.2. Assuming that I have 10 degrees of freedom. If you don't remember about degrees of freedom, it's okay right now. We'll brush up on it in just a minute. Okay? And so I'm looking for this t-value. So let's look at that table that I have included. Where are we at? Let me just do this. I have it right there. So it says if I have 10 degrees of freedom, first of all, I'm going to be looking at this line. A lot of differences on my t-table versus my z-table. I got my degrees of freedom running down the left side right here, and I have all my areas, or the most common areas that I will want to use, running down the right side. And I'm interested in whenever this area, and sure enough, I do have it shaded right here on the right. I'm interested whenever it is at 0.2. I find where these guys happily meet right there at 0.879, and that is, what's going on? I moved. I'm still moving. So that is my answer. We're still moving. 0.879. That's my t-score. Okay? That t-score is going to help me develop a confidence interval for a population mean. Keep on wanting to say sample mean. I'm sampling those videos from last week that I made. So let's talk about making a confidence interval for mu, my population mean. Okay? Now, all three of these are going to be given right here. So I'm just going to breeze through these because we still have a long way to go today, but it's the same thing that I used on the last unit. Okay? So what I want to do is I want you to see the similarities with this. I'm still taking my point estimate, and then I'm either subtracting or adding my t-score. Okay? My t-score multiplied by the standard deviation. So, all in all, again, I'm going to want this up here in the margin, so let me just write it. It's going to be my x bar plus or minus t sub alpha over 2. And we know about this alpha over 2 already. We can work with that. Times S over the square root of it. A very similar formula, we're just shifting our focus from everything that we had with proportions to means. So instead of using my standard deviation for proportion that I had after my z-score, I'm using my standard deviation for mean. Okay. Now, your book likes to hit hard on the error bound, okay? The part that comes after the plus or minus right here, that is what they're going to be calling the error bound for the population mean. All right, so if you want to break that part down, we can. I'm just going to do everything together like we did, and I might come back and talk about the EBM after this first example. If not, I just want to hold on to that, and we'll use it later in this video. So let's go back to our acupuncture people. All right. All right, so I'm wanting to, everything's the same, but I'm wanting to find a 95% confidence interval for the mean sensory rate for the population from which I took the data. So if I was to get every acupuncture client, what are they called? Clients, I guess, that's been through this study, I'm wanting to know what their mean sensory rate would be. If I was to do all of them, again, that would be next to impossible. And since it's impossible, I'm going to have a range of numbers. I'm going to have a confidence interval for it. Now, we already found that my point estimate on this was 8.23 earlier in the video. Okay? And so I'm going to be able to use that in my work for this. So I'm wanting my 8.23. And I'm just going to use the plus and the minus at the same time. You can do them separate if you want to. I like to do them both. And so I need to go get my t-score right here. I'm going to draw myself a little curve right here. And remember, I'm expecting to get 8.23. But I'm wondering how far I need to go to the left and to the right to make it so 95% of my samples would contain the true mean. So let's think about what that leaves for the tails. That means that my alpha is 0.05. That's what's not in my confidence interval. If I divide that by 2, I get 0.025, meaning I have 2.5% over here, and I have 2.5% over here in this curve. We're going to be more interested down here in this tail on these problems, because remember, my t-score is going to be the area to the right. All right, so we have 0.025 is my area, and then my degrees of freedom. Well, remember that one time in class whenever Jillian didn't get to choose her favorite person on the note cards, and she ended up with some random guy that went by the name of Roger Federer, who may or may not be worth millions of dollars and have won many Grand Slams in as far as tennis goes. Yeah, that guy. And Jillian didn't get to pick him? Well, that's because everybody got to choose what value that they ended up to be, or everybody got to choose what person they wanted from that stack except for Jillian. All right? Which means that there was 15 people that got to choose it, minus the one that didn't. There was 14 people that got to choose their favorite card. All right? And so in this case, there's going to be 14 degrees of freedom. There's always one it's always my degrees of freedom, the formula for it is still going to be just 1 minus n minus 1. This is the third video I've made for you guys today, so I'm allowed to have some snafus in my talk. So, to erase all this, we said the degrees of freedom was 14. So, boom, right here on this line. And then the area that I shaded over here in this curve was 0.025. Yep, there's a column for that. And so I see where these two cross at 2.145. And that is my t-score that I want right here, 2.145. Now everything else from here I'm going to be able to get. My S, well, I'm glad I ran my stuff in my calculator. My sample standard deviation, which whether you have a graphing calculator or you're using your phone, or if you have just a scientific calculator, it should be able to spit out a sample for you. It came out, a sample standard deviation, it came out to 1.67. If not, we did talk about how to do that by hand, and it was nasty. All right? And then divided by the square root of n. N is the number of people in my study right here. N is going to be 15, so I divide that by square root of 15. So whenever I come down here, I have my 8.23, and I'm going to add and subtract. I'm just going to decimal all of that out right there. 2.145 times 1.67, and then divide that by square root of 15. 0.925. We can just do 0.92 since we only had 2 decimal places up front. Forgot we were doing 3 decimal places. Either way is going to be fine. I'm not going to be picky about it. So I have 8.23. If I subtract 0.925, I get 7.305. If I do 8.23 and I add 0.925, I get 9.155. And just so we're clear on this guy right here is my EBM, my error bounds for my means. Okay? And so if it was just wanting the error bounds, like some of the homework might, that is just that number that comes after the plus or minus. What do you think? We good? Of course we're not good. We don't have an interpretation. How's our mom supposed to know what's going on right here? So we've got to figure out how to tell this to my mom. All right. My mom only taught kindergarten, so I've got a long way to go on this. But I want to start it off the same way. We are 95% confident. Let me erase this. I think that we're good on that. We are 95%, still erase it, confident that the sensory rate that the population mean, let's throw that word in there, population mean for sensory rates of acupuncture studies is between 7.305 and 9.155. I don't know exactly where it's going to be, but I'm 95% confident that it will be in there. Also, remember what that means as far as the numbers go. If I was to get a different 15 people right here, and I was to measure their sensory rates, then I was to repeat it over and over and over again. If I was to do that 100 times with 15 people, I would expect 95 out of the 100 times I would get the mean to be between these two numbers. In this case, I got 8.23, which I based these numbers off of, but I would expect the mean to be between those two whenever I was to sample 15 more people over and over and over again. Not a lot different going on. Let's talk about the differences real quick, and I want you guys to try one. All right, I've got to get this off my t-table, this 2.145. Right? And I've got to get my own standard deviation. I can't use the p times 1 minus p. I've got to get my s. If it's not given to me, sometimes they'll give you the s up here in the problem. If not, I'll be good to find it in my list. Okay? Otherwise, I'm just following this formula that is on the board. So this one's you. I'm going to work it out. I'm going to hit pause on the video. And I'll show all my work, and you can come back and try to follow it after you try it. So go ahead and hit pause, and I'll meet you back here. All right, here's what I got. Kind of have a very broad confidence interval on this one. And that makes sense because we're going like from 0 to 20 and everything in between. All right, but we was able to narrow it down some. And we have a 98% confidence interval. The fact that it's 98%, that's going to keep it kind of broad as well. That's what I got. If you got something different, please comment to me. Let me know that I goofed something up. There's a lot of math in here to do by myself and a lot of stuff to keep straight. Now, this is a question that tends to throw some people off. Okay. It says that suppose that we know the confidence interval is 42.12 to 47.88. Let's find some of these. I want to know what the error bound of the sample mean is. It's looking for the EBM. Okay. Now, a lot of people are looking for formulas with this and trying to figure this out, and I think it's just a lot better to use your intuition to guide yourself through this. Okay. So remember, we have this normal curve, or T-curve, whatever you want to call it, and I'm not sure what's right here in the middle, but I know that however far I went out this way and however far I went out this way is the same, and it landed me at 42.12 and 47.88. Well, if I look at, I'm wanting that and the sample mean. I'm sorry. Put the sample mean over here. Sample mean, X bar. Well, if I look at what is smack dab in the middle between these two, that's my X bar. So to figure out what my X bar is, I just need to take my confidence interval, the 47.88 and 42.12, doesn't matter which one you put first, and just average them. I'm wanting to know what's smack dab in between them. And so 47.88 plus 42.12, well, of course that gives me 90. It gives me something really nice, 45 in this case. So that means that this middle number right here was 45. And my EBM is just how far out, let me switch colors, is how far out I go in each direction. That's EBM. Now, there's a positive EBM where I went to the right, and then there's a negative EBM where I went to the left. I just want to know one of them. And I'm looking at it, and it's just going to be the difference between where I was in the middle, 45, and where I ended. I can just choose a side, 42.12. And make sure it's positive, so absolute value if you need to. So I just do 45 minus 42.12. Oops, I did 212. It gives me 2.88. This is my EBM. All right, that's my error. That's how much error I'm allowed from that 45 to still be within whatever confidence interval I had here. I'm trying to oversimplify that and not give you a lot of formulas for it. Draw your curve, write what's in the middle, and see how far out you're going in each direction. Okay. I'm not going to make a separate video for this because I just don't think it's going to take that long. And so I'm just going to tag it onto this already kind of getting long video. But just like we were interested in finding n for the population proportion, I also want to find n for the population mean. I want to know how many people I need to survey in order to get to a certain number, in order to get a certain confidence, I guess. And look what happens on this one. I'm not going to show you all the math with it. If you're interested in the math, it's very similar to the math that was on the last video. But look what happened to my t. See, the problem is I don't know what n is. I have no idea what n is. N is what I'm looking for. So if I don't know what n is, how in the world am I supposed to find my degrees of freedom from the chart? I don't know. I don't know how I'm supposed to find the degrees of freedom from the chart. So here's what I want to show you. Remember I said that as n gets larger, it slowly becomes the normal distribution. Watch this. As n gets larger, I'm going to have to scroll on this. So as I go down, 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 all the way down to the n, as my n gets larger, of course my degrees of freedom is going to get larger and larger and larger and larger all the way to infinity. And I like what some tables do on this. This one doesn't do it, but they actually just throw a z down here. If I look at this last row down here, it is actually just giving me a bunch of values off of my z chart. Remember the 1.96 that we used for 95% confidence? There it is. All right? All of them are on there. Okay? Even the 1.645. They just did 1.64 on this, so that will suffice. Okay? So they're all on here on the bottom of my T chart. So I can either go back and use this chart right here, or I can go and just use the bottom of my T chart. Either one's going to be fine for finding it. Okay? Just realize that we've found it with z. Ooh, I'm going to leave that there. I'm going to come back and use this one. So that's why T changed to z. Everything else just kind of moved around like it did on the last one. Okay? I'm going to need that formula. N equals z sub alpha over 2. They're going to have to tell me what the standard deviation is. That's an S, not 5. And this time I get to square the whole thing, since the only thing that was underneath the square root was the n. So let's go back to acupuncture. Okay, I'm wanting to, suppose I don't have the 15 people. I'm getting ready to start my acupuncture study, and I'm wondering how many people I need in that to have my mean century rate with a 0.5 error and 99% confidence. Now, they have to tell you the sample standard deviation on these in order to work these out, okay? So that kind of lets you know which formula you need to pick off the board whenever you're working it. Work the one that has the S in it, okay? And so, I got my N. That's what I'm looking for. I need to go get my z-score for 99%, okay? So, a couple of different places I can get that. I can go 99%. That leaves me with 0.005 over here in the right tail. So I can go here and get it off my T chart, 0.005, all the way over here. So, oops, I moved it to 2.58. Or I can come here, 99% confidence, 2.575. So I'll be happy to accept either one of those. Let's go with the 2.575. I think that'll give me a better answer on this. So 2.575 is what we said. Okay, times my standard deviation, 1.67, all over my error. Now, this is actually my error on this one. We're talking about mean. I'm wanting to be half a point off of on my sensory rate right here. Suppose that we're, what was the other one that we did? Number of hours we watch TV. Suppose I want to be within 4 hours off. I would drop the 4 right here. So that one does not have to be a percentage. It's not going to be a percentage on this one because we're talking about mean. Okay, got a little bit of calculator work to do. 2.575 times 1.67 and divide that by 0.5. That looks kind of small. Remember, I've got to square everything. So whenever I square it, I get 73. It actually comes out to, I get 73.97. Remember, whenever we're finding these ends, we're rounding it up every time. So even if I get 73.01, I want to call it 74. Always round up. Whew. Got through this in less than 30 minutes. All right. That was a lot of information, but hopefully you'll have a while to chew on this. There's only 4 problems I want you to follow. Kicking around right now, maybe doing a Zillow project off this, and so we'll talk about that at a later time. Hope you guys have a great day, and we'll see you next time.